Standing in front of a vending machine at 4 in the afternoon is a strange kind of moment. An apple sits in the corner slot, perfectly edible, entirely capable of solving actual hunger. It gets ignored almost every time. What gets chosen, with a specificity that feels almost involuntary, is something sweet. This isn't ordinary hunger asking to be fed. Ordinary hunger doesn't usually care what shape the calories come in. Whatever is happening at 4 o'clock is more particular than that, and more interesting. Part of the backdrop here is already familiar if you've spent time with this channel before. The early to mid-afternoon sits inside a well-documented circadian dip in alertness, layered on top of however your blood sugar happens to be moving after lunch. That much sets the stage. It explains tiredness reasonably well. It doesn't fully explain why the craving that shows up alongside the tiredness is so specific, why it's rarely, "I want food," and almost always, "I want something sweet right now." For that, we need two systems this channel hasn't covered yet, working together in a way that's more precisely targeted than plain hunger. The first lives deep in a region called the lateral hypothalamus, in a small population of neurons that produce a signaling molecule called orexin, sometimes referred to as hypocretin. Orexin neurons have an unusual property. They're directly inhibited by circulating glucose. When blood glucose is comfortably available, these neurons stay relatively quiet. When glucose availability drops, exactly the kind of dip that can follow a carbohydrate-heavy lunch, or simply the ordinary afternoon decline in steady fuel supply, the brakes come off and orexin neuron activity rises. Orexin is best known publicly for one job: promoting wakefulness. It's part of why a loss of orexin-producing neurons is linked to narcolepsy. But wakefulness isn't the only thing this system drives. A substantial body of research has tied orexin activity directly to food-seeking behavior, not passive hunger, but active motivation to go find something to eat, with a documented bias toward energy-dense, palatable options, rather than whatever food happens to be closest. Piece 1. As afternoon glucose delivery gets less steady, this same neural population that's keeping you from dozing off at your desk is also actively nudging you toward seeking out food, and specifically toward food carrying a lot of usable energy per bite. The second system runs through a hormone most people already associate with hunger, but whose real role is more specific than most people realize: ghrelin. Ghrelin rises in the hours between meals and is popularly described simply as the hunger hormone. Research on its actual mechanism paints a sharper picture. Ghrelin doesn't just create a generic urge to eat, it directly amplifies activity in your brain's dopaminergic reward circuitry, the same system responsible for making things feel motivating and pleasurable, specifically in response to food cues. Piece 2, and the actual reveal of this story. Researchers studying ghrelin's effect on reward processing have found that elevated ghrelin measurably increases the brain's dopamine response to images and cues associated with palatable, calorie-dense food, sugar and fat in particular, more than it affects the appeal of neutral, lower-reward foods like plain vegetables or grains. In other words, ghrelin doesn't just tell you, eat something. It specifically turns up the reward volume on the sweet, energy-dense option sitting 3 slots to the left of the apple, making that option genuinely, measurably more appealing in the moment than it would be at a different point in your hormonal cycle. Put the two systems together, and the vending machine moment stops looking like a willpower failure and starts looking like two separate, converging biological signals, each doing exactly what it evolved to do. Orexin, responding to dipping glucose availability, is actively pushing you to seek out energy-dense food, rather than simply sitting still and feeling tired. Ghrelin, elevated in the same window, is simultaneously turning up the reward value of exactly that category of food in your brain's dopamine circuitry. Neither system is asking for food in the abstract. Both are pointing with real neurochemical specificity at the same narrow category: fast, dense, rewarding calories, which is a fairly precise biological description of a candy bar. This also explains something that trips a lot of people up: why eating something technically substantial, say a full calorie-matched meal that isn't particularly sweet, often fails to fully satisfy a 4 o'clock craving the way a much smaller sugary snack does. The systems driving this craving aren't calibrated primarily around total calories. They're calibrated around reward and speed of availability. A meal can supply plenty of energy and still miss the specific target these two circuits are aimed at. It's worth being clear about what current research does and doesn't establish here. Orexin and ghrelin research spans a mix of animal studies and human work, and individual variation in how strongly these systems respond, shaped by sleep, baseline diet, and metabolic health, is considerable. This isn't a universal, identically timed switch for every person at exactly 4 o'clock. It's a well-documented biological tendency, not a fixed law. And a craving pattern that becomes frequent, intense, or distressing enough to affect daily life is a reasonable thing to bring to a doctor or dietitian, rather than something to simply accept as unchangeable biology. The apple in the vending machine was never really in competition with the candy bar, not biologically. One of them was built to answer a question your hypothalamus wasn't actually asking that afternoon. The other one, sweet, dense, immediately rewarding, was, for a few converging minutes around 4 o'clock, exactly what two separate, entirely ordinary systems inside you were engineered to want.